All right, so we've got the next part here. It says state whether the function is a polynomial function and give the zeros of the function if they exist. And so first off, A is a polynomial. So it's a polynomial function. Because we've got our x terms are descending in power, second power, first power, zero power. The powers aren't ever negative, and so we've got a polynomial function. The second one is not a polynomial function, and because we've got this divided by x right here, so not a polynomial function. Specifically, it's a type of rational expression, but we'll get into that a little bit later on sometime. So first one is a polynomial, the second one is not a polynomial. But we can still find the zeros of the two functions. And so let's go on through here. For the first one, this is a quadratic, and so we can either, again, we have our four different methods. We can factor, we can take the square roots when your b value is 0. We can use the quadratic formula or completing the square. This one here, luckily, is going to factor out first. So we set y, or set f of x, the output, set it equal to 0, and factor this out, and what multiplies to give us positive 8, but adds to give us negative 6, and so we've got x minus 4 and x minus 2. X minus 4, x minus 2, which means that x is going to be equal to 4 and 2. We found our roots. Okay. Next, we are going to be finding the roots of, one second. All right, sorry about that. So we've got to find the roots of this second one now. And again, it's not a polynomial. The top is a polynomial, if you want to think of it that way, that x squared plus 1, that would be a polynomial. But this this whole expression on the right and the equations, and since it's set equal to p of x, is not a polynomial. And so one way to think about that, and let's actually talk about why it's not a polynomial for a second. Another way to write this over here would be that it's x squared plus 1 times 1 over x. Now this 1 over x here, that would be x to the negative 1 power. And if you recall from earlier in the notes, we said that to be a polynomial, that we couldn't have an n value or an exponent that was less than 0. So that's a little bit more explicitly why this one over here is not a polynomial. But even though it's not a polynomial, we can talk about finding the roots. This one's going to be kind of a little bit different case, but if we were going to find the roots where it's going to, where p of x will be equal to 0, we'll set the top equal to 0. Because if we have 0 in our numerator, it doesn't matter what we're being divided by, that's going to still give us a result of 0. And so we have 0 equals x squared plus 1. And if you're looking at this and maybe recalling, this is going to lead us to imaginary roots. So we're actually not going to have any, but let's take a look at why that will be. Subtract 1 from each side. We get negative 1 equals x squared. And then if we were to take the square root of each side, we'll end up with x equals positive or negative I, where the square root of negative 1 is I. And so we don't have any real roots. This function right here isn't going to ever touch the x-axis, so no real roots. There are a couple imaginary roots. One other thing to consider, and this is more just of a preview for later on, this function is going to have a place where it doesn't exist, an asymptote. So right at where we can have 0 and divide by whatever we want, that's not a problem. However, we can't take some number, something like an x squared plus 1, and then divide by 0. If we divide by 0, that gives us undefined. Undefined. And so just kind of keep that in your head that, hey, when we've got a function like this, that something fishy is going to be going on at whatever value of x gives us 0 in the denominator. This one being just x, that number would be at 0. All right. So there we go. Hope that helped. All right, to be more explicit, let's say that. So give the zeros of the function if they exist. So no real roots. Either that would be acceptable, or saying that, hey, they're at positive and negative I. All right, hope that helped.